Okay, so a couple of weeks have gone by since we did the last video, and I was going to do a lot of work on the transmission, but I took the decision to make new transmission gears for the transmission, so they're a couple of weeks off before I can start rebushing and setting that up. In the meantime, we've done a lot of plumbing work. We've done the water pump here, which originally I was going to try and run off the crankshaft on this side of the motor, but because of the configuration of the timer, I took the decision to run it off this side of the motor, and it runs off the cam gear. So this is the pulley for the water pump, and this is the pulley off the cam gear. It's actually a double pulley because it's also running the belt for the oiler. So the cam gear runs at half the speed of the motor. If the motor is doing 800 revs, the cam gear is doing 400 revs. We've got a 2-inch pulley on the bottom there and a 4-inch pulley on the top there, which halves the speed again. So in actual fact, the water pump will be doing a quarter of the speed of the motor, so 200 revs if the motor is doing 800, which will be sufficient to allow the water to go through the motor, but not so sufficient that it pushes it through too quick to actually cool effectively. So, and obviously if we have any issues there in the future, we can change the ratio up the top here to do that. This is what we call link belt, and it's a very good system because these links are removable, and you can extend the belt and make it longer, or you can shorten the belt and make it shorter by taking or adding links to it. So as these belts settle in, they will stretch. We can lift the water pump up to put a bit of tension on it, or we can take a link out if it actually becomes too much. The same with the oiler belt. So the water pump is working that this is the inlet from the bottom of the radiator. The pump then drives the water through there into this pipe, which then goes to both cylinders, cooling the front and the back evenly. The water then drops through the bottom of the motor, comes out of the motor, and then goes to this pipe, and this pipe runs back to the top of the radiator. The water goes through the radiator, cools, and then gets sucked back into the water pump again. So that's the cycle for that. I'm quite happy with the way that's set up. The other thing that we were working on when we looked at it before was the oiler. Now, this is, I don't know what the original oiler was, but this is certainly the position of the oiler on both the two-cylinder glides. So as you can see, I've set up another pulley that runs off the camshaft with this link belt, and then there is these 6 lines. Now this line goes to the main bearing on the crankshaft on this side. This goes to the piston just below the rings, so that it oils the top end of the motor. This actually drops directly over the camshaft so that it's flicking oil around inside of the motor. This one goes to the piston on the back cylinder. This one goes to the crankshaft on the other side, and this one will go to the bearing on the other side of the transmission, because that creates part of the balance of the motor, that it's actually got a bearing here, a bearing here, and a bearing there, so that it's one straight line of bearings. So that's the oiler. I'll establish the drip. At the moment it's set up at about 6 or 7 drips per minute, but once we've actually got the motor running, we'll adjust that by these. So you can actually individually adjust every single one of them. So you may only want about 4 drips per minute at your rings, but you may want 7 or 8 or 10 drips at your main bearing. It depends. There's no seals in there, so you can actually watch it and literally look at the oil coming out of the main bearings. Some will come out to the outside of the motor. The majority should actually be fed back into the bottom of the motor. And the other source of lubrication is when there is oil in the sump and the motor is turning over, it will actually grab that oil and throw it around. So that then effectively means that there's plenty of oil being thrown around inside of the motor, assisting with the lubrication. So the last thing that, well, not the last, but the other thing that wasn't here before was this inlet manifold, which is now established. We haven't put the flange for the carburetor. The carburetor is away getting fixed. It's a simple Chevrolet carburetor. Once that's rebuilt, we'll put the flange on the end there. That mounts the carburetor. So on this side we've done the exhaust manifold, which one end comes out there, one end comes out there. It comes down through here and into an exhaust cutout which runs this exhaust whistle, and then comes back around here into the muffler. Now it's interesting that the muffler is mounted in front of the motor where traditionally it would be behind, but because of the independent spring system and the subframe system of the Glide, the muffler cannot be attached to this frame. It must be attached to this frame because the motor and everything moves independently here. So if you don't want to crack your exhaust system, you need the exhaust and the muffler and everything mounted to this same subframe. Hence the reason why this is all mounted in front of the motor instead of behind the motor. Okay, so electrically we need spark. So what we've done here, this is a 2-cylinder National coil box that I restored. These two lines are the spark plug leads. The red lines will go to the battery under the bonnet, and the yellow and black lines go to earth to create the timer. So it creates a circuit. It's always got positive power from the battery, and the battery is connected to the motor to earth it, and then as these wires get earthed on the timer, as the timer goes round and swipes, it creates an electrical current which creates a buzz at the coil, which creates spark at the spark plugs, and the key to all of that is to make sure that the spark plugs time when the cylinder is on top dead centre. So it's nearly ready to go, a carburetor, and we're ready to start the motor. So hopefully with the next video we'll have a transmission in place and we'll be starting to establish bands, pedals, and then we'll get to steering, and there's no reason why it shouldn't run and drive.